Link Technologies Inc. is your #1 resource for ISP solutions, training, network design, and consulting. We specialize in everything from VPN setup to BGP to keep you ahead of the market trends. Top-of-the-line support for all of your service provider needs. Link Technologies Inc. One call solves it all. Tower Coverage is an RF propagation mapping system that allows website integration for customer sign-up and pre-qualification. Use this data to scientifically plan network expansion and help your WISP succeed.
Thank you for joining us today at the WISP Virtual Summit for this live presentation and Q&A. Please be sure to stick around until the end of the presentation to collect a code for 25 points, which you can submit in the Play to Win tab on your left. So today we're at the fixed wireless and fiber equals hybrid ISPs. Are they the future? We have Chris and Fred today to help us navigate that topic. Let's see, to start out here. So Fred is going to start us out, and he's Director of Engineering with PocketiNet. And Chris is our second presenter, and he's a project engineer at Finley Engineering. Fred?
Okay, Joe, thank you. I want to talk a little bit about the journey that PocketiNet has taken as a wireless fiber hybrid ISP. Just to give you a little bit of background on who we are and who I am, I'm the Director of Engineering and Technology for PocketiNet. We are a fixed wireless and fiber ISP up in the Columbia River Basin, which is southeastern Washington, northeastern Oregon primarily. You can see basically our coverage area with fixed wireless, and then we have a number of areas that we do fiber within that coverage area. All of our functions are in-house. That includes our outside plant for fiber deployment, our technicians that do fixed wireless, all of our installers, our NOC, everything is in-house, and we've been in business for about 20 years. So I just wanted to put a thought in everyone's mind that has somewhat guided us, and we'll come back to this, that everything should be made as simple as possible, but not simpler. And this is a principle that we have used to guide us in our deployments of internet services, not always explicitly, but I think more so as we've learned, we've realized that we want to keep things simple, but we don't want to make them too simple to be able to do our jobs effectively. And so our job really is to connect homes and businesses to enhance their way of life, to provide for their digital needs. And we're living in a world now where inside a home there are just many, many devices of all different kinds that need internet connectivity. You know, but more than computers, we've got smart TVs, high-def devices like that. We've got smart home devices. We've got lots of IoT devices. And these devices are both pulling data into the home, but also pushing data out of the home. And oftentimes, the kind of bandwidth that you get with your typical fixed wireless service is not sufficient. So fiber and higher broadband speeds are certainly important. So going back to around 2015 or so, PocketiNet decided that we needed to really expand into fiber to the home. We'd been doing fiber to the business and some specific homes for a while, but we wanted to really go into providing it into neighborhoods. And so you can see a neighborhood which might be typical of the kind of neighborhood that you would take fiber to. This was one of our first that we did. And in our hometown of Walla Walla, Washington, we have deployed fiber into a number of different neighborhoods that you can see sort of here reflected. And the customers really love it. They love the speeds. They love knowing that it's on and it's reliable. And so that's been a very good thing for them. However, deploying fiber is an adventure. And it's particularly so when we're doing it in volume, like you would do in a fiber to the home kind of environment. We really work in three primary ways of deploying fiber traditionally. One of them, and maybe the easiest, is what we would call underground greenfield. So going into a neighborhood that's just in the process of being developed, where the trenches for the utilities are open. It's quite easy to lay the conduit in there and then come back when the development has been completed and pull the fiber through with already having the paths in the ground. That makes things very easy and inexpensive. Sometimes, though, if we're going into an existing neighborhood, we have to do underground because there may be restrictions in the community about actually doing overhead or aerial fiber. There may be no overhead infrastructure. Many neighborhoods don't have power lines running, up in the air. Everything's been put underground. And so we have to come in and do what we call brownfield deployments of fiber. And that usually requires horizontal boring machines and all sorts of ancillary equipment, trenching where that makes sense in some cases, but of course we don't want to disturb the environment that we're operating in, and we want to keep things looking good. So oftentimes that's the only way we can do it. So we call that brownfield for underground. And then aerial fiber, when we have the infrastructure and we can hang the fiber up on poles and so forth, then that's a good approach. So we've done all of those. As we've went into doing fiber to the home, and we have several hundred fiber to the home customers now, we discovered that there were a number of things that can impact our time to actually deliver service to customer, as well as the cost to deliver services. They include things like drilling conditions. Do you have rocky soil, which can be a real problem to drill through? Sandy soil can be a problem because when you're trying to do directional drilling, often it's very difficult to get the drill to go to where you want it to whenever it's trying to push through sand. Weather impacts. In our area, we don't get a lot of really bad winter weather, but you can see there from that picture that we do get some. The ground does freeze. When it freezes, we can't really do much work outside, and so that delays fiber deployment activities in the winter. We also have a number of local regulatory issues. There are times when the local authority will pave an area, and then they put a moratorium on doing anything to cut up the pavement that's just been put down. That may last for several years, where they don't want any of that disturbed, and that impacts how we would deliver particularly underground fiber. We also have to deal with pole attachments and anybody that might already be on the pole, and other regulatory issues associated maybe even with concerns over putting devices up that are going to impact the neighborhood aesthetics. So we have a lot of issues that potentially can impact the time and cost. And beyond that, doing fiber deployment requires a lot of equipment. It's very expensive. You can get easily into the hundreds of thousands of dollars to purchase and then maintain that equipment. And so these are things that all have to be considered when we do fiber deployment. And in our case, what they really led us to do was to say, is there a better approach? Have we made things too simple, just saying, well, if we want to put gigabit internet or 100 megabit internet to customers, we have to do fiber? And so we looked around and we really decided, no, we need to adapt our approach to our environment that we're operating in. When we're doing greenfield and it's very easy to put conduit in, then fiber makes a lot of sense for the access side to distribute that to customers. When we're doing brownfield, it doesn't make so much sense. And in fact, we pretty much stopped doing brownfield residential fiber because of the reasons that I mentioned earlier. But we are doing greenfield still. Surrounding infrastructure, if they're not utility poles in or very close to the neighborhood, then it may be difficult for us to take fiber in aerial. That's an inexpensive approach when we can do that, but oftentimes those infrastructure items are not there. Home density can make a difference. If we need to go larger distances to reach our customers' homes, then fiber makes less sense because we have to pull it those distances. And looking at different backhaul options is important too, because while you might think, well, if we're going to do multi-gig backhaul, we have to use fiber, that is no longer the case. Technologies are there to be doing multi-gig backhaul with wireless technology, and I'll talk a little bit more about that in a minute. Another thing that's very important, though, is to determine what kind of take rate, because ultimately the take rate that we get in a neighborhood determines the revenue and therefore the return on investment that we can achieve. So we want to know that information and some accuracy before we actually make the investment. And again, I'll talk about that as we go further. So there are a number of different technologies, and as I'd mentioned, if we're going to move from just doing fiber to doing a hybrid approach that involves both fiber and wireless working together to achieve high-speed broadband and beyond connectivity, then we need to make sure that we understand what those technologies are. And there are a couple different application approaches that will drive us into our technologies. One of them is where we have decided, for instance, you look at the top picture that I have here, and you can see there's no infrastructure above ground to hang any fiber on. It's definitely brownfield. You've got lots of landscaping and concrete and other things here. You might have a road that you can't really be cutting into. And so this is a prime kind of an environment for us to deploy what we would call 5G fixed wireless. It's also called wireless fiber, or just high-speed wireless to these homes that can deliver fiber-like capabilities. And there's some technologies that are available now to do that very well. One of them that we've used successfully is 60 gigahertz fixed wireless. We've used a number of different systems based primarily, what you would find out there is based on 802.11ad technology. But 802.11ay technology is showing up on the scene now that supports 10 gigabit throughput in a mesh deployment. And so these kinds of things are important for us to be able to use. Wi-Fi 6E is coming along, opening up the 6 gigahertz band. And so this is another area that we want to take advantage of to deliver 100 megabit plus into these neighborhoods where we can't really pull fiber to the house. Now, another way of looking at this is to deploy fiber in the neighborhood, but maybe need to connect it using wireless, because the really large expense for fiber is in providing the backhaul. And I've shown you a little neighborhood down here in our market where there are poles in the neighborhood, so we can use aerial fiber delivery in the neighborhood, but there really isn't a good way to get fiber there. So using multi-gig, multi-band wireless backhaul is a way to go there that might combine a licensed radio with, say, an 80 gigahertz radio to deliver multi-gig service that is truly reliable in all conditions. Can be an approach that works very well. It's also important to look at planning and marketing. Return on investment is the way we decide how to go into the neighborhood, and we look at all the various costs that are involved and what our return would be. And one of the important inputs to that is to identify the neighborhoods where we're going to get a good take rate that will provide us that revenue. And so we do that by targeted marketing, by having a website where the potential customers can go and register their interest, and we aggregate that and look for clusters in neighborhoods that make sense. But that lets us know before we actually start building anything what the likely take rate would be, and therefore what the success is going to be in that neighborhood. And so we put all those things together, and I think it's worked very well. It allows us to deploy hybrid fiber wireless solutions to customers much faster, much less expensively, and still provide them the kind of service that they would expect if they had fiber running up to their home. I wanted to mention just very quickly that there are a number of opportunities that are coming along where we might be able to apply this very effectively. One of the upcoming opportunities is the FCC's Rural Development Opportunity Fund auction, which is going to be held in October. And in fact, the short form application period just opened up today for this. But this is an opportunity where the government recognizes that hybrid solutions are part of the way that we can effectively deliver service to customers. And so they have made accommodation for these types of technologies in order to deliver services up to and including gigabit service to customers. And so I'd encourage each of you to take a look at hybrid solutions, because I think it really allows us to have the best of both worlds, the highest performance, but do so in a cost-effective manner. Thank you for your time.
Thanks, Fred. Let's see. So Chris is up next to continue the discussion.
Thanks, Joseph. I guess just to give you a little background, I'm Chris Konechne with Finley Engineering, and we come from a more traditional telecom consulting engineer type role, and as such, we're very well versed in the fiber world. However, with the advent and improvements of wireless technologies, more and more of our clients are using fixed wireless as a complementary strategy to build out their networks and provide service in much the same way that Fred has just alluded to. So I'm going to focus pretty heavily on the fiber side of things. First off, just why fiber, and Fred really picked up a lot of these points. There's a lot of different cases where you might want to use fiber, and really it's just picking out what the best case is for fiber and use it where it's appropriate and where it makes sense, both from a network side and financially. Obviously everybody knows there's nearly unlimited bandwidth and backhaul capacity when we talk about fiber. Another thing is funding options. As we just talked about, the Rural Digital Opportunity Fund is coming up, where you receive a low or zero weight for that gigabit tier. So that can really play into the financial side of things. Another thing to talk about, it seems like every day there's a new wireless technology and speeds are growing at leaps and bounds, where you could be switching out equipment and trying to upgrade services across the board. We're seeing packages and bandwidth demand at the home is doubling at somewhere around the rate of every 3 years. So trying to keep up with that on the fixed wireless side can be challenging. Whereas if you have that fiber asset, whether it's in the ground or on a pole, that's really a long-term, 30, 50, maybe even 70-year asset, and it can really provide that long-term stability. And the operational costs are, can be somewhat lower depending on, individual situations. Also, there's inherent deployment challenges with fixed wireless. If you're in a area southeastern U.S. with 100-foot tall pine trees, that's just kind of a nightmare scenario for a lot of fixed wireless deployments. And last, you just may have certain customers, especially on the business commercial side, that might just require fiber if they're, schools, financial institutions, larger businesses, things of that nature. There's just nothing that's going to get the job done quite like fiber will. So if you're new to fiber, this can all be very overwhelming. And when people come to us and ask, how do I deploy a fiber network? It's not that there's one right answer for every situation. It's picking the right tool out of the toolbox. So we'll dive into first, aerial fiber. We like to just, kind of a crossroads situation, aerial buried. Some reasons you might want to look at aerial fiber is oftentimes it can be cheaper to deploy. I'll show some slides coming up here, but we can typically see fiber on an aerial side 30 to 40% cheaper, faster to deploy. If you live in a northern climate where the ground freezes, aerial deployments can typically go year round, and it's much faster to string cable on a pole than it is to get it through the ground in nearly every situation. Time to find and repair faults. If you've got a tree branch hanging on an aerial line and it's snapped or bent too much, it's very easy to drive that route, find those faults, quickly repair them, get that network back in service. Where If somebody nicked a fiber on some sort of road project, it might be a little more time consuming to find that. Rock can be an issue, especially on the buried, so that you're saving a lot of costs there. And then restoration of the network that we already talked about. Where aerial fiber can kind of go off the rails, make ready costs. So particularly in urban, town settings, there's standard NESC clearances that you need to meet, both from the power line and from the ground to the communications attachment space. It's the burden of the attacher, the new provider, to make sure that all those clearances are met, and also you can have to kind of fix other people's problems that are existing there. So that can often quickly drive up the price of aerial deployments. Another thing to consider are attachment fees. If you don't own those, there's an ongoing attachment fee that you're going to have to build into your model to account for all that. That can kind of hurt the business case. Reliability, if you live in very tree heavy environments, northern climates, again with a lot of ice and wind concerns, might not be the best solution for you, particularly on backhaul and backbone lines. There's kind of two general flavors of aerial fiber. One incorporates some sort of steel support member. Most commonly, you'll see this as strand and lash, although you might see what's called figure-8 fiber, which is basically just an internal strength member steel cable that comes with the cable on the fiber side. You'll also see sometimes aerial conduit, which is, instead of a fiber cable mated with a steel cable, it would just be an aerial pathway. But this is kind of the most common setup, and this is up until recently, this is been 99% of fiber deployments. Some things to keep in mind here. This all has to be run in what's called the communication space. So you're dealing with those lower ground clearances and those make ready costs. These all have metallic elements. So you have grounding and bonding costs both at the poles and at the home. These cables are pulled pretty tight. So oftentimes, compared to an ADSS deployment, which we'll get into, that can be a bigger load on the pole, which leads to more pole change outs and higher costs. One thing in favor of a strand and lash, actually two things, is since we are in the comm space, we're not dealing with high voltage qualified workers. So, from an operational and an installation point, that's going to keep the cost lower for you. And another big benefit to any sort of steel strength member is the ability to do mid-span drops. And what that is basically that steel member has enough strength that you can take off, not just from any pole, but you can take off from the middle of that span and run directly to the house for the drop. That's not something that's widely or easily done on the ADSS side. You hear the term ADSS a lot. If you're not familiar, it's all dielectric self-supporting cable. This is a fiber cable that is encased in a Kevlar, or different manufacturers have different proprietary terms, but basically there's a non-metallic woven material that acts as a strength member. So any time that you cut that cable, you need to support it in order to take the weight of that cable. This can be a very, very cost-effective solution, particularly in areas with high make ready, especially if you can convince the power company to grant you access to the power space. So under the National Electric Safety Code, what you can do is you can run this cable right up underneath the neutral. And that just makes, the vast majority of your make ready costs go away. And then in order to deal with those worker qualification problems, because you do have to have high voltage qualified installers to put this in, you can run your terminations down into the comm space or even below, and that can really make for a cost-effective network. And we've seen the cost on this product and various attachments and materials come down dramatically in just the last few years. Some of the con sides are, as we said, the power company does not have to give you access to that pole space. So that's something that if you're not the power company or the pole owner, it's something you need to work with them to try to convince them that it's a good idea. And the other thing that's hard to do is mid-span taps or overlash. So it's not to say that it can't be done. There are a few manufacturers that do allow that, but it's something that you kind of have to build in up front. And then last, buried fiber. Buried fiber can make sense in a lot of situations where you don't have access to pole structure, or other things might make it impractical from a financial side to do that. In this case, you're seeing what looks to be relatively clear poles, but you'll also notice that they're doing plow work, which is oftentimes much cheaper than a directional bore, and that can be either direct bury fiber or conduit. A few more cons on fiber. Rock and cuts and repair can be a really big problem when we talk about buried fiber. The last thing I want to get into is some numbers in the feasibility side of this thing. We've done about 15 counties in Minnesota, and I realize these are highly regional costs, and honestly they're probably like a year or two old, so these probably need a little touch up. But what I want to do is show the order of magnitude that these different scenarios can cost. And we kind of see that 30 to 40% difference between an aerial deployment and a rural, plow type deployment, and then that urban bore number that can really spike things up. In those feasibility studies, what we did a lot of times was we proposed a fiber to the home solution for an entire county, and then we also came back and proposed a very robust hybrid fiber wireless, where we would pick up towns and kind of that small islands of fiber concept that Fred had talked about, and we would connect all that with fiber. We would have fiber backhaul at all the towers, and then we would provide a robust high-speed fixed wireless platform out of there. Initially we were kind of looking at a 25.3, but now these networks have evolved to offer 50 and 100 meg packages, and we were really looking at building these backbones and networks as a step to fiber and providing higher speeds in the future. And these are kind of some of the results, and it really shows the delta of what we're looking at. We're looking at an average cost of in the $2,500 per customer neighborhood, all in on the hybrid fiber wireless side, and we're in the $9,000 and getting close to the $10,000 mark per customer on a lot of these full fiber to the home builds, and a lot of these projects opted to move forward with the hybrid solution. So it really just kind of shows how fiber and wireless can operate better together.
Okay, well, thanks guys for all that information. If you needed to get in touch with anybody, this is all of our contact information here. And as a thank you for joining this session, here is a code for you to enter in the Play to Win tab on the left of your screen, and you can claim 25 points. So let's see. We're at the Q&A section at this point. I guess we can just open it up amongst ourselves right now to just go over some points. And I guess that last slide of yours, Chris, was pretty interesting. I mean, I think it really shows the case of hybrid. Some of those price per homes were so dramatically different. I think it's pretty compelling to to see those numbers and explore how the two technologies can come together. Those are some big differences. What when you're designing a system like that, what does hybrid mean? I know the country's a big place. There's so many different deployment methods that you could do, but when you put wireless and fiber together, what does it actually where does each have a home?
Sure. So as I mentioned, on those specific instances, what you're looking at this is Midwestern cornfield areas, so very flat. We're trying to these counties range from 600 to over 1,000 square miles, and we're trying to build a redundant ring that would provide backhaul to anywhere between maybe 6 to 10 towers, and then we're trying to locate equipment on those towers that can shoot out in the 5 to 6 mile, maybe a little farther range, and provide high capacity fixed wireless to the rural farms in those areas. And then also with those backbones, a lot of times we're able to pick up small pockets of towns, anything in that 200 to maybe up to 1,000 home location. A lot of those towns in our area don't have access to a coax or cable provider. But also, to kind of go to a different area of the country, we work with some providers out in Colorado where there's these little mountain pockets of homes down in valleys, and they will flip that model backwards, and they'll provide multi-gigabit license links and then do fiber to the home from there. So it can really kind of pop up. The wireless component can pop up at any point in the network. It's just picking the right tool out of the toolbox.
Yeah, for sure. So, there are definitely some of these deployments where it's really still doing the traditional WISP deployment, just using fiber as the backbone and going into the, city centers is what you're saying. And then in other cases, if I'm correct, and then in other cases, you may use a fixed wireless link to get to a heavily treed area and do fiber to the home. And then, I don't know, and if I missed it, I'm not sure, but maybe Fred mentioned it. A third type of a hybrid network might be where you're doing, fiber to an area and then doing the higher bandwidth, 60 gigahertz type deployment to the last, couple hundred feet to the home.
Yeah, one of the, give you an example of a neighborhood that we recently deployed to. It consisted of some existing homes that were already there, what we would term brownfield. We had fiber running into this neighborhood, but they were expanding the neighborhood. So what we did was we had fiber coming in. We put a couple poles up around the edges of the neighborhood. We put 60 gigahertz fixed wireless shooting into that existing area, and we were providing 125 meg, 300 meg, 500 meg service to those customers using wireless in 60 gig with a fiber backhaul. The other part of the neighborhood where they were in the process of building out, they had open trenches over there. So we were able to put conduit into that part of the neighborhood and deliver fiber all the way to the premises. So we actually had in that neighborhood a very good mix of underground fiber installed in greenfield conditions with a hybrid fiber wireless installed into brownfield conditions in the same neighborhood. And so those kind of approaches work very well. I like the idea, what Chris mentioned, that these are tools in our toolbox, and we really want to make sure we're using the right tool, because if we do that, we can deliver the quality of service to every customer, but we can do so that's in a cost-effective way for everyone.
For sure. Yeah. I think there's a lot of different deployment options. I mean, you had mentioned these greenfield deployments, and then you were also talking about take rate and going through the business case and marketing. How, like, what is your thought process or the formula for those greenfield deployments? Are there like a certain number of homes already like committed to be built, or like how that just seems like a big risk, or there's less to build out costs, right, at that point, but you still don't know if anybody's going to actually move in or what that schedule is, right?
Well, that's true, but it's very cheap to drop conduit. In fact, we go around to a number of the developers and we give them conduit, say, drop this in your trench when you've got your trenches open. And then we may develop a relationship with them so that we're talking to them about how that neighborhood's laid out, where we're going to put our handholds, where we're going to, how we're going to architect that whole thing. But the cost of actually just putting the material down in the ground, even if we don't get a really high take rate, is still pretty low because we're not having to actually go and do any digging in that process. And so our philosophy generally is we look for every opportunity to put conduit in greenfield developments. When we get to brownfield, that's when we are really focusing on deciding what neighborhoods are going to be able to deliver a high enough take rate to basically justify the costs that we have to put into it. And so we do that using interest aggregation. Everyone that comes to our website that's interested in getting service, they go in, they put in their name, their address, they say what services they would like. If we don't offer that service right now, we store that information and watch for clusters of interest to show up. And when we start to see clusters of interest develop, then we will often send one of our salespeople into the neighborhood, go door to door, and actually ask people, what are your needs? What are you doing with internet? So that we can determine, is there really a need in this neighborhood? Would they be interested in having a fiber-like delivery of service there? Or are they okay with more of, just limiting to 25 by 3 or something like that? And once we make that determination, then we can figure out, okay, what's the best way to deploy service to their neighborhood? Do we do a traditional WISP deployment? Do we do something that's more of the hybrid fiber wireless deployment?
Gotcha. Okay. Well, I think we're coming near to our time. I guess, let's see. Is there any major, like, what would you say is your biggest lesson learned or challenge or notable item that you had to when you were starting your assuming a lot of us were already doing wireless and the fiber is a new thing, what was maybe your single biggest thing to investigate more on the fiber side before if you're ready to jump in?
Chris, I don't know if you want to go first on that.
Sure, I'll take a stab at it. Like I said, we come from the telecom world, so we're very comfortable with fiber and are becoming more knowledgeable with wireless and how those systems work by the day. So we are getting a lot of clients from the wireless world coming to us and asking us how to implement. And I think it's just starting out with a good plan is the best piece of advice I can get anybody that is getting into fiber. So whether that's, going out and adding personnel to your staff that has fiber expertise, or, working with a consulting engineer or even a manufacturer to understand, what kind of dollars you're going to have to put into this, whether it's, starting up your own construction crews or working with a contractor, and navigating that laundry list of issues that will drive you to that decision about how do I deploy, whether it's aerial, buried, etc. is just getting someone on your team that can help guide you through all these decisions. That's probably the biggest thing I could say.
Yeah, I agree with that. I think it's very important. Another thing that is a consideration is that as a fixed wireless provider, you may not need to have franchise authority to operate within right-of-ways and utility easements within the various jurisdictions that you may be in. But if you're going to be doing fiber, you're putting it on poles, you're going down the right-of-ways and having access to those areas, you're going to need to have franchise authority. which means that you really need to understand how your local government regulates these utilities. And that's very important. And I think the other part of it that goes along with that is developing relationships with the people that are setting these regulations, so that when you want to particularly do a hybrid kind of solution, that you know who to talk to, and you can educate the government authorities, homeowners associations, anyone who's a stakeholder, to educate them in what you're doing and help them understand that this will be safe, it'll be cost effective, we won't be there disturbing all the environment for that long with these types of solutions, and it's going to provide a reliable service that will last long into the future. I think once they understand those kinds of things, they'll be very welcoming.
Right, agreed. Well, there definitely is a lot of discussion to be had on this. So thank you everyone for joining us today for this live presentation. Don't forget to head over to the group discussion tab where you can ask us any remaining questions you have. We hope you enjoy the rest of your time at the WISPA Virtual Summit and have the good rest of your day.
Thank you for tuning into this session at the WISP Virtual Summit, proudly presented by Perseem. Perseem is a unique networking solution that helps WISPs measure, analyze, and optimize the quality of experience they deliver to their subscribers. Perseem helps WISPs lower churn, reduce support calls, and increase revenue. To learn more, visit perseem.com.